Now the red knob is the mixture control, and the basic purpose of adjusting the fuel-air mixture control at altitude is to decrease the fuel flow in order to compensate for decreased air density. As you go to higher altitudes, the air gets less dense, and you need to decrease the fuel flow in order to have the proper ratio between the air and the fuel. If the fuel-air mixture gets too rich, the engine's going to run rough. Now, an example the FAA is going to give you is they're going to say to you that during run-up at a high elevation airport, you notice a slight engine roughness. It's not affected by the magneto check, but it does get worse during the carburetor heat check when you put the carburetor heat on. What is the most logical initial action to do? Well, the most logical initial action would be to see what happens if you put the mixture control to a slightly leaner setting, and here's why. When you put the carburetor heat on, you've got hotter air going into the carburetor. Hotter air is less dense, and when the air is less dense, the mixture is going to get a little bit richer. So if the engine roughness gets worse when you put carburetor heat on, it means that the engine is running a little bit rich and that it's getting richer with the carburetor heat on. So the first thing you'd want to try would be a leaner section of the setting of the mixture control and see if that takes care of the problem. Now on descent, you do want to put that mixture control back forward. You leaned it going up, you want to put it back forward going down. If you don't do that, if you fail to readjust the mixture control on descent from high altitude, the fuel-air mixture can get excessively lean, and that also makes the engine run pretty rough.